Hello, everyone. I'm Emmanuel Dioha by name. I'm here today to actually present my 3 minutes presentation in the ongoing IMC meeting. Today, I'll be trying to discuss a comparative study on the native synapses datasets, which most of us, I think, know about, and comparing them with the NSGDDP datasets, and to see the possible values added in these NSGDDP datasets. So I'm Dio Emmanuel from Seoul National University. So the quest, as we all know, for the climate extremes, actually, extreme events happening, especially within last year, this year, we've seen temperatures and rainfall patterns that are very extreme. But the truth is that reports have shown that in the future also that these events will be more. And it is important that to be able to actually predict these events and be able to precisely predict them in the future, it is necessary that the data sets actually that we use in our studies matters a lot. So I also have these discussions with friends that also, even those of us who are integrated assessment modelers also, our model outputs are as good as our data inputs actually. So the inputs is very, very important. So it is in the light of this actually that we try to do some evaluation studies to see if actually these new data sets have some better improvements and which will now be very important in future studies and so on. So basically what we try to do is we checked some of the studies in Africa. Our study domain is Africa. We checked some of the studies in Africa and we find out that most of the studies have been using the traditional native GCM datasets, but also these studies also have also shown that actually that the GCM experiments actually have also some uncertainties in them. Their results also have some uncertainties. And then, so for our studies, we tried to actually use 22 NSGDDP datasets and compare them to 22 synapses datasets, native synapses datasets. And then we tried to use CHIPS and CPC. We used 2 observation datasets because we were using the variable precipitation in our study. So the study area is Africa. And so basically what we did, our data sets, we tried to actually do some pre-processing using CDO 2.4 and then the Python. And we tried to do some pre-processing of the data set. Because of time, I might not really have time to go into that, but the details are here. And also at the reference here is also a full detail of the whole work done in these references. So here is just a schematic diagram of what our methods look like. And yeah, some of the statistical methods we applied. So, but moving straight to the results, actually, as you can see here that if we compare actually the results we've got in the model evaluation, what we got here actually, you see that from the model evaluation, these are the NSGDDP datasets, these are the synapses datasets. We find out that the NSGDDP datasets actually tried to mimic the observation better when compared to the synapses datasets. This will be explained later in details. And then this is the temporal plots which we try to show. And then on the spatial plot, actually, we also try to show here, this on the right side is the NSGDDP, while on the left side is the synapses. And on the right side here, you see that we even use the correlation figures, which are shown there in details, it can be seen. And the bias figures, we show that the NSGDDP data sets perform better than the synapses. We did some check of precipitation also along the latitude, and we found out that around Central Africa, where you have very heavy rain precipitation, we found out that the NSGDDP datasets were able and capable to, at least to some extent, mimic better the CHIPS observation data, while most of the models we noticed here actually overestimated the CPC observation datasets. But all this we discussed in detail why and all that in our illustration. Then from our statistics, we also checked from the statistics, you can see that the red plots are for the GDP models, and they try to plot towards one, which shows that actually they were performing better with respect to the observation data sets. And then here also the TSS and IVS scores we showed here also, you can see that both on the IVS scale and the TSS scale, on the C column, which is for the NEST-GDP data sets, actually, sorry, the B column, which is for the NEST-GDP data sets, you can actually see that they performed better compared to that of the Synopsys data sets. Then we tried, we also tried to do some seasonal analysis where we try to show some of the plots on a seasonal scale, and even on a seasonal scale, we noticed that for instance, West Africa, we know that the dominant, we use the DJF, MMA, and JJA. So for the seasonal investigations, and you can see it, for instance, West Africa here, the dominant rainfall pattern is JJA and then SON. And then we try to using the IVS to also rank the models, do the ranking of all the models based on both regions, the 9 regions of Africa, and on a seasonal basis. So that's on a scale average summary of what we did. And in our official work, we're trying to quantify the socioeconomic impacts of exposure to climate extremes using the GDP data set, since it has shown to outperform the Synopsys data sets. And we also try to explore changes in compound extremes over the African continent. And this is the reference for this work. Thank you very much.